So our speaker tonight is Dr. Hulbert. He was scheduled a couple months ago, you might have saw, and he had to cancel for some medical reasons. And I knew when he canceled, we do get some people cancel on us, we're like, hey, where are they at? We're on a cruise, but we know he would never miss us. So he is back here today to fill in for that spot he missed a couple months ago. I know with new folks and some folks who don't know, so Dr. Hulbert was the collections manager for the Florida Museum of Natural History. He graduated from UF. Did you get your PhD at UF? And he went away to get a job, but he came back to the school in 2000. So he spent 23 years, 22 years as a collection manager. I hate to say the place was a mess when he took over, but the place was a mess when he took over. If you took a tour of the place, there was boxes and boxes and crates of fossils everywhere. I mean, thousands and thousands of them. He numbered them, logged them, assessed them into the collection. Did a great job with that. But what he'll always be remembered for doing is reaching out to the amateur. Yeah. That trend started with David Webb, who was still there when Dr. Hulbert went back. And I don't think there's a museum, a university-run museum in the country that has a better relationship with amateur fossil collectors in the country. And about 10 years ago, I invited Dr. Hulbert to come set up a table at Fossil Fest. I don't know if you were giving out permits back then. Maybe it was. And I know at the university level there was people who told him not to do it because it's a for sale, a retail fossil selling environment. He came anyway, and he's established a great relationship. He furthered that relationship he already had with people, getting people to sign up for fossil permits that otherwise wouldn't have one. And he started a new generation because our new girl, Rachel, who is going to be the new collection manager as soon as she gets her PhD here soon. She's grown up in the school, or grown up in her college years there, knowing that the museum has always come to Fossil Fest. And so to her, he's taught her that's just what you always do. It's not a new thing like it was with Dr. Richard. If you find horse or tapir, don't bring it when he's here because he's going to take it when he leaves. You can bring anything else. Saber cat's gone. He don't care. He'll leave it here when he goes. But anyway, he's been retired now for 3 years, and I remember I asked him one time years ago, "What are you going to do when you retire?" And he said, "I'll be able to study what I want to study." And to my knowledge, that's all he does. I don't think he's going on cruises or taking vacations. He's studying fossils, probably horses and tapir, and probably some of the bigger beasts at Montbrook. But everybody, warm welcome for Dr. Richard Hulbert.
Thanks very much for that introduction. Yeah, we're going to turn the lights down a bit.
It's my job.
So the talk I'm going to give today is sort of cobbled together from two presentations I gave at scientific conferences last year. And so I've tried to adjust a lot of the slides, the text and things to simplify it a bit, since these were conferences with professional paleontologists. But you know, there'll be some talks with slides with a lot of text. Don't worry, there's no final exam, no tests. And again, I saw that there were some new people here, so many people in the room, though, have been at the Mount Brooke site, but I'll just have this one refresher slide and go over it. So the Mount Brooke site was discovered in 2015. It is up in north central Florida. So here's this location, site Gainesville's about here, Ocala's there, it's sort of in between, a little off I-75. We've now excavated an area of about 525 square meters, or to put that in perspective, it's about 1.2 basketball courts. The age is been now narrowed down to about 5.9 million years. That's a new research one of our students did, so that's in the latest Miocene epoch. It's extremely fossiliferous. Over these almost 10 years now, we've collected well in excess of 250,000 vertebrate specimens. Now, a lot of those are little fish teeth and fish jaws and fish spines, but some really good stuff too. And about half of that has been identified and cataloged. And what I'm focusing today on are the mega herbivores, the really big guys, the elephants and the rhinos, and trying to show you that we now have something that's in the similar scope and size and numbers that's getting close to famous sites like the hot spring site in South Dakota or other big famous mega herbivore bone beds. Now, I wanted to emphasize that, again, mammals are actually relatively rare. They're only a few percentages of all the total fossils we find. Most of the stuff we find are things that were living in rivers. And so up here in the upper right is a partial fish skeleton. That's probably a freshwater drum, although I'm not 100% sure. So the freshwater stuff is the most common stuff that is associated or articulated. We get lots of turtles, we get whole alligator skeletons, lots of freshwater fish. We do get a lot of shark teeth and ray stuff, but that's all isolated, and I believe it's mostly reworked from the beds and banks of this ancient river. And so they are actually older than the freshwater and terrestrial stuff. This is a picture of the site, and we're going to get a little bit into the geology. The lowest level we dig we call stratum 3. It has these layers of sands and clays that alternate. The darker layers are the clays, and then the lighter layers are sands. As you go deeper, the sand layers get thicker, and they actually get less consolidated. It's kind of odd, but the sand gets softer and more crumbly as you go down deeper. At some later time, that bed was then cut by these channels that we call stratum 2A. And those are the two beds that produce most of the fossils. There's a few other beds at the site, but they don't have nearly any fossils. And although the fossil species are the same between stratum 2A and 3, essentially, they're in much different proportions. So it's almost like we have two different fossil sites. And all of the mega herbivore skeletons come out of stratum 3. Let's see. So again, I'm not going to go over any details. If you really want to get into the geology, we can. But I wanted to emphasize stratum 3, that's where we get the mega herbivores. In stratum 2, there's a lot of great diversity, a lot of great turtles and alligators, and even a lot of otters and freshwater mammals. And an odd toe bone or vertebra or wrist bone of a mega herbivore, but no skeletons. Now, what do I mean by a mega herbivore? You might have a good sense that it means big and herbivore. So it's, by definition, it's an animal that eats plants, and the adult size is more than 1 ton. The average is more than 1 ton. I like to just think about, some people try to put aquatic things like dugongs into the category. I like to think of just as the terrestrial stuff. And so these are your familiar things from zoos in childhood: elephants, rhinos, hippos, and giraffes are the living examples. There are many fossil examples as well. And their ecology is very well studied, and so they play extremely important roles in the habitats where they live, and they're regarded as keystone species, which to an ecologist means if we kill them off, the habitat degrades. So they are really keeping the habitats healthy. And one of the reasons is the vegetation diversity and seed dispersal abilities of these guys. Okay, so as I mentioned, we have these essentially almost two different localities. And I want to emphasize, when I put this pie chart up in Excel, it gave me these orange and blue colors that was the first choice. I didn't purposely select it. So this has nothing to do with basketball. So the stratum 2A, as I said, does have some mega herbivores, the orange pie chart here, but no skeletons. But look at the abundance of mega herbivores is about over 90% of the mammals that we get in stratum 3. So, like I said, it's almost like we have two different fossil sites and they sort of complement each other. And again, just to emphasize, 0 skeletons versus 48. Even the non-statisticians in the audience will say that's probably significant. All right, so just again, how many people have been here to the hot springs site? So a whole bunch of them. So this is another example of what is classically called a mega herbivore bone bed. It can be other things in the fauna. In this case, the mammoths are the two mega herbivores. There are two species. There's Columbian and I believe some Primigenius as well. We have at times discussed doing something like this with the Mount Brook site, but the geology and the humidity factors, and also our problem is also groundwater. We are below the surface, and so it's, you know, why don't we have basements in our houses around here? You know, the water will raise up, so we would have to like do something really crazy or dig a big ditch and keep a pump running or something to keep the bones dry during the wet season. Another famous mega herbivore site, maybe less well known to many people, is this site near Waco, Texas, with 24 mammoths. You may have seen TV shows or read the book about the snow mass site in Colorado with 35 mastodons, a few mammoths, and ground sloths. This one they did all collect, so you don't always keep them in the building, but sometimes you let them come back to the museum. And then finally, how many people have been here to Asheville? Okay, so this is a very impressive site. The initial collections did take the specimens back to the museum in Lincoln, but then here now they're sitting in what they call the rhino barn. These are rhino skeletons, but there's also horses and other things in here as well. So most fossil sites, you do not get a lot of mega herbivores. It's just numeric sense that they are rare in the landscape compared to smaller animals. And so if you're getting at least a relative representation, at most fossil sites, maybe you get, you know, a few mega herbivores, but every once in a while you get these mass concentrations, and that really allows you to do a kind of research that you can't at other sites. And this is some of the stuff you can do, and most of it's essentially studying them as populations and doing a lot of statistical studies, looking at how the site includes a lot of different ages from juveniles to full adults. You can see how the skeleton and the teeth changed as the animals got older. Assuming the site has both males and females, you can see what differences there are between those two things. So lots of stuff you can do with mega herbivore bone beds. And so we'll be doing a lot of this stuff at Mount Brook. Our main problem is that we can collect these things a lot faster than we can prepare them. And so everything has to be plastic jacketed for these big bones because it's pretty crumbly stuff. And so we build up a huge backlog of plaster jackets. And so that's what's really holding back the research. But we're getting there. So let me now go over some of the basics of our 3 species of mega herbivores from the Mount Brook site. And the first one is the rhinoceros, teleoceros. Teleoceros is maybe a familiar animal to a lot of you. It's an unusual rhino in that it has relatively short, stubby legs, a big barrel-shaped body, broad skull, and these were one of the most common mammals that is found in the fossil in North America in the middle Miocene to the late Miocene, up until about 8 million years ago. Now our site, you might remember, is more like 6 million. So our site is one of the last major bone beds with teleoceros. So we might be able to get some clue from the Mount Brook site about why this animal is declining in populations and will eventually, in about another 1 million years ago, go extinct. One of the interesting things, again, we talked about ontogenetic sequence, so we have some young juveniles. The one on the top there, those are all the baby teeth. This is a full adult. You can see the preservation is not great for a lot of these, but this is a full adult male. One of our skeletons was a female, and then in parts of the back of the skeleton, we found these extremely young juvenile or probably fetal bones. We didn't find the whole fetus, but there was quite a few bones. So these are wrist and ankle bones. We also got some ribs, the head of the femur, and a few vertebral fragments. You'll see several maps of the site. So we're looking down as if we're looking at like a regular map. So we're sort of looking down on top of the site. The blue is where we have dug, and the white is where we haven't dug, at least yet. So we have sort of two different pits that there's a sort of a gap between them. You can see the rhino is somewhat scattered, the skeletons we found so far, although somewhat concentrated in the northwest part of the site. And we're actually working that part of the site again this spring and finding a lot more bones of these skeletons that we previously discovered the last couple of years. So that's number one. Number two, the rarest of our megaherbivores is the mastodon. So we saw that mastodon tooth that Joe found. And that is the common Pleistocene mastodon, Mammut americanum. That's the common one we find here in a lot of Florida. That's the one you see skeletons of at our museum, Tallahassee, most other museums. But there were mastodons that lived back in the Miocene and Pliocene. But for some strange reason, we're not really sure why, they are much rarer. They became very abundant in the Pleistocene in the ice ages, but they're always at these Miocene sites. It's typically you only have one individual. We are lucky we have 4 different individuals at least of Miocenes, of mastodons. The picture here you're seeing is actually from Oregon. There's some debate about the taxonomy, the systematics, how many species there are, whether this name Mammut matthewi, which you see a lot these days, is really valid because the type specimen is a piece of crap. But anyway, the teeth are pretty similar. The cheek teeth in particular are pretty similar to the Pleistocene one. So if you just had an isolated one, it might look a little strange, maybe a little crests are a little bit lower on average, but it's pretty similar. But the tusks are very different. The upper tusks are much skinnier, and then somewhat like a lot of gomphotheres, they have a long chin, and you'll see a picture in a second, with larger lower tusks than you see in the Pleistocene. And we do get these out of the phosphate mines as well. So these are our 4 individuals. Again, we have essentially a sequence of young, very young animal to sort of a teenager. We don't as yet, unless they found one today, because we were digging today at the site, a full adult. And that's also sort of hindering our comparisons. But we have a tiny little baby that's actually an associated lower jaw and skull and postcranial skeleton. This is the next older one. It's still a juvenile. These are still the 2 baby teeth. The guy in the upper right has the last baby tooth and then the first 2 molars. The second molar was not erupted yet. And then our oldest individual is this one, and this is actually enormous. This jaw is almost as long as this table, believe it or not. It goes to about here from that. And so again, it has this longer chin or symphysis than you would see in a Mammut americanum, and then some pretty significant lower tusks as well. Again, it's the rarest of them, so there's less of them, and for the most part, they were all concentrated in this one center part of the site. And this could easily have been, they could have all been part of one herd that died, and they were all simultaneous, where the other ones we think are more a gradual accumulation, but this could have just been, one herd that tried to cross the river in a flood situation. The one bone that's sort of outside this area is just an isolated maxilla, so it's technically not part of a skeleton, but I threw it up there anyway, just to emphasize that the skeletons of the mastodons are just in the center of the site. And we're trying to dig back to this area. We've try to find that a rare adult of this version. This is that maxilla I just mentioned on the right side there. So again, these are the first juveniles of Miocene age mastodons from North America. Like I said, it has this lower tusks with the chin. And we're hoping that the malproxatic will help us try to figure out what species these Miocene things are and how they're related to the Bone Valley, the phosphate mine sample, which we mostly have isolated teeth, but there's a few. We have one jaw. Barbara Fight has a very nice jaw. And we also currently can't tell the postcranial elements of the the mastodon and the gomphothere. All right, and speaking of gomphotheres, so again, that was what was brought up here. So if you're not familiar with the term gomphothere, they were the most diverse group of fossil elephants. They are worldwide in their distribution. They range from the southern tip of Africa throughout all of the old world. They got into North America, all through North America. Eventually two of them got into South America, all the way down to Chile and Argentina. So other than Australia and Antarctica, there were some gomphotheres, and there are multitude of genera and species, and they lived, or their range, I think, probably close to 25 million years. So they are the most abundant group, and in Africa, there's a branch of the gomphotheres that then gave rise to the elephants. So the elephants are sort of very derived, specialized gomphotheres. And this is a classic gomphothera tooth. It's not quite like the mastodons, which have these sharp ridges. It has these sort of low, lumpy sort of crests that form in this pattern. And we'll give you a technical term. These three cusp patterns are called trefoils or trefoils.
You think that's Platybelodon, or is it possible to tell?
One thing about gomphotheres is, other than size, and then there's some advanced ones that get much bigger and add more crests, but within that, their cheek teeth are damningly similar to each other. So you really need tusks and lower jaws and even skulls to figure out what exactly you have for sure. I mean, it could be Platybelodon is a fairly small, and this is, you can tell by the narrowing that this is the third molar, so this is the biggest one in this individual, and it's, in a Rhynchotherium like that, this third molar would be that, much bigger than these, so it quite could be. And I don't really know my old world gomphotheres that well. Now, I should mention, in case you hadn't heard the news, so this is an exhibit at the Florida Museum. The museum is now closed. For the next year and a half, the public museum is closed for renovations. So don't drive up to Gainesville on a random whim to think you can go into the museum or the butterfly rainforest or anything. I don't know how widely that news has been dispersed yet. So our gomphothere at the Mount Brook site is called Rhynchotherium. Rhynchotherium is one of the last of the gomphotheres in North America. Its primary distribution is in the southern band of the United States, from Southern California all the way through New Mexico, Texas, and it ends up in Florida. It's characterized by a shortening of the lower jaw. So in a typical ancient gomphothera, again, their chin would stick out to about here, and then there would be tusks. In the Rhynchotherium, the jaw is relatively short for a gomphothera, and it also takes this bend compared to the rest of the jaw. And then the tusk would naturally stick down. This one was sort of affected by compaction, so you can sort of see the drawing on there. The other weird thing about the Rhynchotheres is their tusks, instead of just having ivory like modern African and Asiatic elephants, which are just ivory or dentine, gomphothera tusks have enamel along one of the sides of the tusks, the upper tusk, that we call the enamel band. But in your general standard gomphothera, that band would be straight and just along the side. But what's going on is, as this tusk grew, it was actually rotating in its socket. And so this enamel band has ended up on the top over here and not on the side. And so that's a characteristic of Rhynchotherium. There are some people who tell you that it's just one species of Rhynchotherium. The oldest to the youngest. I think that's wrong. I favor at least 2 species. And our species would be the more primitive type. Here's the same jaw that you were just seeing before on exhibit, but this is back when it was in the field. And I've actually done some Photoshop magic to move the tusk back into its correct orientation. We now see that that individual is a male. This is a female. They have much smaller lower tusks. So again, we talked about sexual dimorphism. And in fact, a lot of the females at the site have lost their lower tusks in life because they still have the alveoli for the tusk, but they filled in with bone. And in fact, it's hard to see on this picture because it really wasn't prepared when I took this picture last year. But I just was in the prep lab, they're still working on it. And they finished preparing it. And this is the tusk from the left side. The right side alveolus is now prepared. And I thought the tusk was just missing because we didn't see it. In fact, it was already lost because the alveolus has infilling of bone in it. So here we have an individual that has the tusk on one side and not on the other. Most of the other females, both tusks are missing, so that's sort of an odd one. Here, this is what I was talking about, the trefoil patterns. And what's interesting about this Rhynchotherium is it's on both sides of the tooth. And that's called double trefoil, and that's a specialized feature. Another thing we can see in our sample is that the tusks, the lower jaws don't start out at that steep angle. When they start out as juveniles, they're almost horizontal. And over their lifetime, it deflects down. There's sort of an old phrase that ontogeny recapitulates phylogeny. You might remember that from your biology. That means you sometimes look more primitive at young stages, and you see more derived or advanced features in full adult stages. And so that's what this is going on with this Rhynchotherium. It starts out looking like a Gomphotherium with a straight symphysis, and then as they get older, it deflects down. Again, sexual dimorphism is also prevalent in the upper tusks. Again, this is another male with this big, thick enamel band. It's a relatively straight tusk. In terms of a diameter, it's more than my hands. It's a pretty thick thing. Whereas this is a full adult because this is a third molar here. That's about this big around. And they also are curved and downward. Whereas these would have been straight or pretty much going straight out, much more, they wouldn't be just downturned. So there's considerable sexual dimorphism there. Just some data, because I'm a numbers guy. Again, this up or left here, this table here, again, this is sort of the bane of my existence in that, yes, the prep lab's done a remarkable job. So about half the specimens we've collected have been prepared, but I know there's some great ones, including this male that we haven't seen, this skeleton, that haven't been prepared yet. That's really holding back our research. But again, one of the remarkable things about the Mount Brooks sample is that we don't tend to find a lot of isolated teeth. We find the whole jaw, or we find the whole jaw plus a skull, or we find an upper jaw. There are a wide range of ages, from full adults to the teenagers to young ones. Although interestingly enough, we don't find, remember the little baby mastodon I showed? That's like a first year individual. We don't get any of those at the Mount Brooks site. We do get probably things that are fetal, but these guys were apparently smart enough to not cross the river with their little babies. Maybe that's why they were more numerous than the mastodons. And then we have some data here. Again, I think we sort of cover this at some other points in the discussion is, these teeth are erupting successively. Each successive tooth is larger than the last one. So you start out with the last of the baby teeth, the DP4, deciduous premolar 4. First molar, the green is the second molar, and then the third molar. Those of you in the back can probably distinguish the squares and the circles. The circles are the Mount Brook specimens, and the squares are the Bone Valley specimens. Pretty similar in size, at least. Whether they're the same species or not, still to be figured out. And I should want to acknowledge the help in Barbara Fight allowing me to measure her sample of Bone Valley Rhynchotherium. Her sample is even bigger than our sample in terms of number of measurable specimens. So a lot of those dark dots are from Barbara's collection. And again, here we see sex ratio. So far, a little female dominated, which is often what you see in herds. We can't tell, usually you can't tell which sex it is until at least the young adult stage, because the dimorphism hasn't really kicked in. All right, now, so you can see how many more skeletons of the Rhynchotherium that we have than compared to the rhino or the mastodon. In fact, sometimes when you're in the right area, it's, oh no, here's another one. And they do seem to come, and I can remember this specifically. You'll see a picture of me in a second of digging right about here. As we were digging the site, we were primarily going from north to south. And we had stripped away the 2A layer first, and then we were working through the 3A. And it would come in waves. We would hit these zones, which it was just, we came up with the term bone jam, it's like a log jam of bones, or like pickup sticks, if people still use those. So the bones are just jammed into one another, one on top of another, probably multiple individuals. They didn't all die at once, so we do have layering. So this is not one big mass catastrophe like the rhino site in Nebraska or something like that. But there do seem to be clusters of individuals whose carcasses are now intermingled, so they probably did die at about the same time, if not in the same flood event or something. Let's see here. And you get the same sort of pattern here. The darker the color, the more bones there are per square meter. And so you do sort of see that it's not evenly distributed. There's some places in the site where we get no proboscidea bones. The lighter color, there's got maybe 1 or 2 bones in here. And then there's others which are part of where these skeletons are that are just loaded with bones. All right, so this is life in the bone jam. So we've got Dr. Block, my former boss here, me up at the top there. One of our volunteers, I can tell from the hat, is Bill Buhai, who's worked a lot with us for a number of years. And so there's, here's a bone, there's a bone, so whatever. So Dr. Block is uncovering a humerus, he's doing the fun job. I'm making a plaster jacket. You can see we already flipped one that day, it's up there. Bob is doing that. If we're really lucky, there's enough space in between the bones so that we can make one jacket per bone. If you're not lucky, the 2 cluster together, and then you have to make some really big jackets, and you'll see one of those in a second. And it's tough to make really big jackets in soft, sandy sediment. It's one thing to make big jackets in hard, rocky sediment, but if you made a jacket, the moment of truth is when you flip it over. And so we have learned the hard way how to make jackets at Mount Brook. Although sometimes the graduate students don't follow the instructions. If I wasn't there. And now sometimes, so the bone jams they're not articulated, but they're just associated. But sometimes we do get articulations. Here we've got a skeleton just sort of splayed out. So you've got the rib cage coming up here. They haven't been uncovered yet, but the vertebral column ran right underneath this guy's head. And then the other side of the ribs were under here. And then here is the scapula and the humerus. It's not a full skeleton, but it's definitely one individual, a big chunk of it. And then this is the most complete skeleton. This is one that took us a long time to collect from when it was first discovered. And it was found in 2 major clusters of somewhat different degrees of articulation. This upper part here is a nearly fully articulated right and left forelimb, rib cage, and section of vertebrae. It's almost like it tipped over on its side. And so this is the right leg that was on top, and then the vertebrae go through, and then the left side, the left limb is on that side. We were really lucky in that you can sort of see there's a little gap right above me, right above the bag, and we were able to make 2 plaster jackets out of this. And this was still a plaster jacket that weighed more than a ton. And you'll see that in a second. And so that one, the right leg was fully articulated, essentially from the shoulder blade to the toes. The left leg was a little more messy. I'm not sure if these are the femurs that go with this individual. They seem a little on the small side, but we haven't prepared these yet to know for sure. This is a large male. The tusk is right, so this is the skull and jaws, since this is a magnification up here. So the lower jaws of the skull are in full articulation. You can see the orange of the tooth enamel is bright for the lowers, uppers are above that, a little more obscure. So the skull and jaws are right here. There was a tusk only in the one side, the left side. And then as we dug around more, you can see several pictures of this. So this looks like, how did we get this picture? Because it's like from the side. This is what they call photogrammetry, where you take a whole bunch of pictures and then the computer turns it into a 3-dimensional object, and then you can take slices of this. So this really wasn't taken from above, but you're sort of seeing. So again, this is where the other arm or forelimb used to be, and this is this whole mess of the vertebral, the 2 scapula, and the left leg. And here's the skull up here. So we're now digging around here, and we started finding the pelvises. So here, so this is the right and left pelvis. We cut a whole bunch of the foot bones of the hind feet as we were digging around these. So these 2 got their own jackets. And then so this was a big jacket, and this was a really big jacket. So you sort of see the phases here. So on that one, we're just starting to get the bones covered with sediment and some paper to pack in. Above me there, it's like the first phase of jacketing, and this was the final phase. I think Rachel counted up about 12 layers of burlap and plaster. And then we used hydrocal, which is the strongest plaster you can typically get. Okay, so how do we get these things out of here? So fortunately, we're digging in an active quarry, and the landowners are very friendly. In fact, this guy is the son of the landowner, and he's now in charge, really. And so he brought over one of his big drag lines and helped us flip this thing over. So that's him and Dr. Block and a couple of our volunteers. And so this sort of makes like a little time lapse. And so that was successfully flipped over, and then we hauled it up with their machine and loaded it on one of their trucks, and took it out. And they first took the truck because they have a weigh station, because again, they're selling sand, so normally when the trucking company comes in, they weigh the truck, and then they weigh the truck on the way out, so they know how much sand they put in here. But they weighed their truck and figured out that this jacket weighed 1,800 pounds. And that wasn't the biggest one that we had to get out, I think. So, how did all of these mega herbivore bones get here? Well, for the proboscideans, like I said, it definitely looks like we're talking about carcasses of animals. So we're not talking about animals that died far away and then the bones were transported by water long distances to accumulate at some place. But we're not talking often about perfect skeletons. So the carcasses somehow got to the fossil site and then got somewhat disarticulated by the currents. But pretty much the general proportion of the numbers of bones are similar to that of a skeleton. So if you just think of your skeleton, you have a lot more ribs and vertebrae than you do skulls or humerus. And that's the general proportion that we're getting here. So maybe we're missing a few of the smaller bones that tended to float away, or at least get, downstream that we haven't found them yet. But in general, we're getting that. We're also getting more of these hyoid bones than I've ever seen at any other site. These are the tongue bones, the bones that help support the tongue. And they're very fragile, and you very rarely see them, but we have, I think, at least 10 or maybe 15 of them so far. Again, from youngsters to full adults. So, as I've said, we think, and there's a lot of text here, but, and this is mostly my ideas, and so I'm calling it a hypothesis. It's more a guess, because some of this can't be sort of scientifically proven, but there's a fair amount of evidence for this, at least I think so. So we think that all these herbivores start out as carcasses. Probably the animals died by drowning, possibly, we think this is a big river. It's somewhat like the Swanee in that it had probably fairly steep banks, but made out of sand. So you could imagine an elephant trying to climb down that bank and stumbling and maybe falling and breaking a couple of limbs and dying right there. But somehow you gotta get death, and it's gotta get into the river. So that getting the whole carcass into the river is sort of the key to our understanding of this site. I'll show in the next slide. We think there that the main scavengers are animals which do not do damage to bones. There's been a lot of study of what happens to mega herbivore skeletons after they die, because people are very interested in determining whether in North America, is this mammoth or mastodon, was it killed by humans or was it natural causes? In Africa, where they're also interested in, when do humans start hunting these mega herbivores? And so there's a lot of study about what happens to mega herbivore carcasses and under natural conditions, and how do you tell if humans are involved or not? So there's a lot of evidence of that, and we'll get into some of the stuff. So we don't think that these things were scavenged by things like borophagine canids, which have hyena-like jaws, and which would eat a lot of the bones, particularly the softer ones, which would leave tooth mark impressions. We don't see any of that. So we think it's things like the freshwater animals, the turtles, the alligators, the fish, crustaceans down to, small little worm-like stuff and everything. Those are the main things that would have eaten all the meat and all the soft parts. No major role by terrestrial scavengers. You would think, alligators will certainly scavenge, and on smaller animals, they, one or two alligators can completely consume it. But when it's a mega herbivore, because the alligators are cold-blooded and can't eat that much meat at one time, a couple of big mouthfuls of, muscle from an elephant, and that'll keep that alligator sated for months. Wow. And so, unlike hyenas or canids, who can scavenge down an elephant carcass in a week or so, the alligators, wouldn't be able to do that. Okay. Like I said, there's no marks on the bones, bite marks. There's no weathering or water wear that would indicate that this carcass was sitting on the surface outside of the water. Again, we get whole mandibles together, right and lefts, much more common than isolated teeth. So again, they haven't been transported very far. And even when you don't have articulations, you have associations, because we have seen matching right and left sides. We have, particularly for very young ones or very old ones, bones of the same ontogeny and size together, and we can rearticulate them once they're prepared. All right, well, thank you for your attention. Again, I want to thank the Hodge family who own the property and allow us to work there and give us help with their equipment. All of our volunteers who do most of the digging. These are the people who run the fossil site, particularly in my retirement age. Zach Randall's a museum employee, does all this wonderful photogrammetry. Again, thank Barbara Fike for letting me study her specimens, and our funding sources from the NSF while it still was active, and the Hulbert Foundation. Okay, thanks very much.
I'm going to show and tell. I'm going to let Jacob go for it. Jacob, Poor, you want to come up?
So I brought in a few interesting things tonight to coincide with what I was told Dr. Hulbert will be talking about, but also to ask some people's opinions on some specimens I acquired recently. Also wanted to show this off. Finally got into using paraloid B72 to coat my fossils with, and I wanted to show off the first one that I really did a good coating on. This is a woolly mammoth molar from Siberia. This is something that I brought, hoping Dr. Hulbert will be able to take a look at and verify the identity of. It's a Gomphothere molar from China. I was told it was Platybelodon. It's in absolutely incredible condition, so I'm hoping to get a good ID on it. But if it can't be identified, then that's good to know as well. Plus, it ties in with the presentation about big things that lived during the Miocene on land, even if it's not from this continent. So got a really interesting sloth molar, sloth tooth recently. I'm still not entirely sure what species this is from. Joe says it's Paramylodon. I honestly don't. I would love to see a picture of some of the dentition in the jaws to compare it to, because I mean, at least when I looked at the skull, I didn't see anything like this. Maybe if anyone has a picture of the bottom jaw with all the dentition, so I could compare this to, that would be really appreciated. And this I just want to make sure is actually real. It's supposedly a dinosaur track from New Jersey. I was hoping someone could take a look at it and say, oh yeah, no, that's actually real, versus, oh no, they just took a flat slab of rock, painted some color on it, and then called it a track. Because you can never be too careful. If it is real, it's probably then it would be from the early Jurassic, so probably about 200 million years old. Yeah.
Pat Appleborn.
Went to Edisto Island, South Carolina, over February and March, and we're going to say this is bison vertebra that I found on the island. A bison tooth. Did we say this was tortoise?
Tortoise.
Thanks, man.
Tortoise. Nice chunk of tortoise. And pond turtle, where the neck comes out of the shell. Nuchal. There we go. See, it's all Latin to me, okay? Turtle. That's it. Thank you, Ben.
Oh, now you got a drop in it.
Now he has 6 fossils.
Joe Brandon.
So I know we don't normally bring in nice stuff when the museum's here, but aesthetic appeal doesn't necessarily equate to scientific value, right? Because this, we'll see.
It'd make a great display in their case.
They got better,
You're rolling the dice.
maybe. This is about the prettiest mastodon tooth I've ever found. I found 4 teeth from this animal. Only one was exposed to the river to get stained. The others were coming directly out of clay, so they all fell apart. I don't know if you guys have any underwater jacketing techniques. I've tried Scotch cast, aluminum foil, 50-50 if they work or not. But I managed to collect most of the pieces to all the teeth, and this one it only came apart in 2 major pieces, and there's just a little bit of fill. But it has really incredible glossy enamel. That's about the most unique mastodon tooth I've ever found. Lightning in it, yeah, I've been hit by lightning twice diving for water, or diving in the water for fossils, sorry. So that explains.
You didn't stutter before that.
I did not, no. I've been coming here since I was this big, and I was way smarter then than I am now. So that's gotta be due to the lightning. But it has really cool lightning patterns in the enamel, and it's definitely one of my favorite teeth. What river? Good one. Fossil River. This comes out of the Withlacoochee River. So up in North Florida. Nobody wants to go there. Big gators, big gators. Big gators.
That was pretty nasty quick anyway when the rains got.
No, it's very clear right now. You can see the gators coming from about 10 feet away, but they are getting more active. I had a baby gator that somebody had been feeding come up to the boat a couple days ago, which that's really unfortunate because that's basically that thing's death sentence. But yeah, cool stuff.
Amazing stuff so far. I'll show some more of the artwork that my sister's been working on with my help. You might have seen some of them at Fossil Fest when we had them on display at a table. And look at this. How many of you remember we brought a T-Rex in last time? Raise your hand if you remember.
Yes.
Well, this is one of his cousins. Meet Dalton Despletosaurus. Yeah. 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 Ironically, Dent is his name. Her name. Achycephalosaur, Dracorex, which is currently controversial, but we drew it anyway. Here's one from prehistoric Swan Lake of Russia. Allura titan, Odessa.
Okay.
Large duck-billed dinosaur. How many of you seen Prehistoric Planet on Apple TV Plus? Well, this is one of the duck-bills that was featured in one of the episodes. One of the last non-avian dinosaurs at the end of the Cretaceous. From Jurassic Park.
Gallimimus?
Yes. Gabriella Gallimimus.
That's cool. Has some claws on them.
Yeah. Make sure you aren't in the way when they're flocking. And one thing in our series is that ornithomimans have this habit of doing just about everything fast. They eat fast, they sleep fast, they even talk fast. And the one that I wanted to show you the most, because Easter, one of my favorite holidays, is coming up, is this one.
Wow.
Meet Oviraptor. His name is Aki, which is a nickname. His real name is Osborne. Can you guess how I came up with that name? No? Yeah, Henry Fairfield Osborne, who named Oviraptor in 1924, though he was doubtful of giving this animal that name because he thought that there was more to its character than it just being found with a nest of eggs. And several years further on, it was found that he was right because, according to other Oviraptorosaurus skeletons, it was actually brooding the nest rather than stealing from it. Oviraptorosaurs have to be some of my favorite theropod dinosaurs there are because they're just so strange and bird-like. They have a short piga-style tail like you'd see on a turkey or a peacock, and some of the very early ones, like Incisivosaurus, which had bunny-like buck teeth, and Caudipteryx, which had short teeth, were actually the first dinosaurs to be found with feathers. And
Wow.
we even know that some of them had stripes on their feathers. And the crests on the top of their heads, which most of them had, were probably used for display. Now, can you guess which bird today would most likely be like Oviraptor, which has a crest on its head?
Cassowary.
Yeah, the cassowary. So that is a pretty interesting thing. And though most Oviraptorids were small, Oviraptor would only be about 5 feet long and about this high. The very largest one, Gigantoraptor, could reach lengths of up to 26 feet
Wow.
and stood well over 8 feet tall. So, just think about it. If you're walking in Cretaceous Asia or North America, which do you think would be worse? Angering a dromaeosaur, which is like a flightless hawk or eagle, or angering an oviraptorosaur, which is like a prehistoric cassowary? Which do you think would be worse?
Thank you, guys.